Kirchhoff's law. So let us discuss about Kirchhoff's current law and Kirchhoff's voltage law. So let us consider first one as Kirchhoff's current law. So as we know that Kirchhoff's current law states that the algebraic sum of all the currents meeting at a junction is 0. So if you consider this particular example here, so we have taken some example here. So there are a particular junction to that 3 different currents are entering. So if we consider that, so the algebraic sum of all the 3 currents will be equal to 0. So entering current will be taken as positive and the leaving current will be taken as a negative. Or the another concept what we can say is the sum of the entering current will be equal to the sum of the leaving current. So both will hold good. So entering current will be either as taken as positive and leaving current will be taken as negative, or we can take that one as entering current will be equal to the leaving current. Next, so let us consider a Kirchhoff's voltage law. If we want to consider Kirchhoff's voltage law, according to the Kirchhoff voltage law statement, the algebraic sum of the potential drops in any closed circuit will be equal to the EMF acting on it. So if we consider a simple example here, so I am going to consider a single source along with 2 resistors. Let us consider the voltage source is V and resistance is R1 and R2. The algebraic sum of the potential drops in a closed circuit. So if you consider the potential drop across current flowing, let us assume it as I, that is from the Ohm's law, the drop across R1 will be IR1 and a drop across R2 will be IR2. So according to the statement, the algebraic sum of the potential drops, so that is drop across R1 and R2, so that is IR1 plus IR2 will be equal to the EMF acting on a circuit, that is here the voltage source we have taken is V. So that is what your voltage law says. So whenever we want to solve a particular problem, we should follow any one of the method. So example, so for the Kirchhoff's current law, so let us take one simple example with few circuits. So this is a junction, this is I1, I2, I3, I4 and I5. So you can consider any one condition. So I will explain both the conditions. So then we conclude that any one condition we can be taken because both will result in the same thing. So according to the statement, the algebraic sum of the current will be equal to 0 in case of a KCL. So the entering current will be taken as positive, that is entering current will be taken as positive and the leaving current will be taken as a negative. If you consider this particular junction here I1, I2 and I5 are the entering currents. So all are positive and I3 and I4 is the leaving current. The algebraic sum of all the currents at a junction is 0, that is I1 is entering positive, I2 is also entering positive, I3 is leaving negative, I4 is leaving a negative and I5 is entering positive, that will be equal to 0. The algebraic sum of all the currents at a particular junction will be equal to 0. Or one more concept what you can say is the entering current will be equal to leaving current. The same equation you can consider. So what you can do is whichever the positive terminals are there, we can write it on one side and the negative terminal we can shift that one to the RHS side. So now you can see I1, I2 and I5 are entering. We have written one side, that will be equal to I3 and I5 on the I4 on the other side. So from this we can conclude that the sum of the entering current will be equal to the leaving current. That's what we can have a final conclusion while solving the problems. That's what we can use. Similarly, if you go for the KVL, the main 2 concepts we have, one is the voltage source. If you consider a voltage source, it has 2 terminals, one is negative terminal, another one is positive terminal. So if you are traveling from a negative to positive, that is from minus to plus, that is considered as a rise in potential. So I want to consider the voltage as positive. Since we are traveling from lower potential to higher potential, it is considered as rise in potential. The voltage EMF source will be considered as a positive. So if in case of a reverse case, first we have a plus, then minus, and we are traveling from positive to negative, means from higher potential to lower potential we are considering. Then since we are traveling from higher potential to lower potential, we want to consider the voltage source as a negative. This is the condition we should follow in case of a voltage source is given. If in case of the drop across a resistor, if the current direction is given here and whatever the current direction we are assuming, if both the directions are one and the same, then we, as we know the concept that current always flows from higher potential to lower potential, that is plus to minus, as we have seen in the case of voltage, plus to minus that is traveling means we should consider this one as a negative. Then let us consider one more example here. So whatever the current direction we are assuming is a clockwise, and the direction of the branch they are given is anti-clockwise. So this will become plus minus, but we are considering a clockwise direction, that is minus to plus we are traveling. So the voltage drop will be considered as positive, or in general we can conclude that if the current direction what we are assuming and the branch current what they are given both are same, the voltage drop will be a negative. The branch current and the current direction loop current what we are assuming both are opposite, it can be considered as a positive. That is what the condition we are going to assume for the voltage law. Now after learning this, let us consider a simple problem so that we can make use of these concepts. So let us have a simple circuit. So this is a given circuit. In between that they are given some switch and the multiple sources. So the first source will be 120 volts, second source is 100 volt, and the third source is 20 volt. And this is a switch, and here the resistor values are 2 ohm, 10 ohm, 1 ohm, right? So now here we need to find the voltage drop across the terminal A and B. Between these two terminals means we need to find the voltage drop across the resistor 10 ohm for two conditions. First condition is when switch is open, and the second condition is when the switch is closed. For these two conditions we need to find the solution for this. So now let us go for the first condition. If you go for the first condition, when the switch is open, so when the switch is open, what we can do is we can neglect this particular circuit because the switch is open. So we can neglect that and we can write the remaining circuit. So the circuit will be like this. So this will be a circuit. They will write down the values, what all the values they are given. So now we need to find the drop across CD. If you want to find the AB. If you want to find the drop across AB, first we need to find out what is the current flowing through the 10 ohm resistor. If you want to find out that one, we should apply the KVL here. How many loops are there? There are 2 loops are there. Let us consider this as loop 1, the current flowing this one will be I1, and let us consider this one as loop 2, the current flowing through that will be I2. Now by applying KVL for the first loop, if you apply, so here clockwise will traveling minus to plus, so minus to plus voltage drop will be positive 120 minus, here we should assume the current direction, so the voltage drop is always negative, that is minus 2 I1 minus 10. This 10 ohm resistor belongs to both the loops, so and I1 I2 direction are both are in opposite direction, so it will be I1 minus I2 will be equal to 0. So if you further simplify this, we have written it as 12 I1 minus 10 I2 will be equal to 120. That will be the first equation. Similarly, if you write the KVL for the second equation, so here I will start with the 10 ohm resistor, drop is always negative, minus 10. Since we are writing the loop equation for second loop, it will be I2 minus I1 minus 1 I2 plus to minus we are considering, so it will be minus 20. Again plus to minus we are considering, so it will be minus 100 will be equal to 0. Further, if you simplify this, the equation we are going to get will be 10 I1 minus 11 I2 equals 120. And the first equation we had is 12 I1 minus 10 I2 will be equal to 120. If you simplify both the equations, we are going to get the values of your I1 and I2. I1 we are going to get as 3.75 amps and I2 will be minus 7.5 amps. Now we want to find the voltage drop across AB, that is voltage drop across the terminal 10 ohm resistor. This is A and this is B. So VAB we want, so the direction of current should be flowing from A to B. Now if you consider the current I1 is flowing like this and I2 will be flowing in the opposite direction. So your VAB will be equal to the resistance 10 into the two currents are flowing. The same current is I1 minus the current is I2. So the equation will become 10 into 3.75 minus of minus, that will become plus 7.5. So if you simplify this, we are going to get the answer as 112.5 volts. So that is what the voltage drop across AB we are going to get as 112.5 volts in case of a open circuit. Now let us consider the same circuit when it is the switch is closed. So once again we will write the circuit. The switch is closed, so we are going to short that one. So this is what the thing what we have. So here we have us 120 volt, 2 ohms, this is A, this is B, this is 10 ohm, this is 1 ohm, this is 20 volt, this is a switch what has been closed, this is 100 volts. So now we want to find voltage drop across AB. Now you can consider here, since this particular portion is connected in parallel, so when there is short circuit, the resistance will be 0. So now 0 ohms is in parallel with 1 ohm. That is, if you have two resistance in parallel, we know that the condition is R1 into R2 divided by R1 plus R2. Since one resistance value is 0, 0 multiplied by anything will be 0. So we can rewrite the circuit like this. As it is shorted. So this is A, this is B, and this is a 10 ohm and this is a 100 volt. Since these two are parallel and this is shorted, so this resistance can be neglected because all the current will be flowing through the least resistance path, that is 0 resistance path. Since there is some resistance is present, no current will flow through that, so we can neglect that, right? So we can replace that one by a short circuit. Now we want to find the voltage drop across AB. So we know the concept from the parallel circuit that the voltage drop across parallel circuits will be one and the same. Now we can see this 100 volts is connected in parallel with the across the 10 ohm resistor. So from this we can write the drop across VAB will be 100 volts directly. This is how we can find out for the when the switch is open it will be 112.5 volts and when the switch is closed it will be 100 volts.